Well, good afternoon, everyone. Welcome to the CLF webinar, Concrete Steps to Net Zero Practical Strategies for Low Carbon Construction. My name is Alicia Couto, and I am a program specialist with the Emission Neutral Building Information Exchange, or MBIX. MBIX is a part of an Alberta Eco Trust Foundation program. And so Alberta Eco Trust Foundation is a trusted leader in advancing environmental and climate solutions across Alberta. We collaborate with diverse partners from government, industry, not-for-profits, and Indigenous communities to create a future where both people and nature thrive. Since 1991, Alberta Eco Trust has mobilized resources, delivered innovative programs, and supported impactful projects that protect and restore natural ecosystems, reduce greenhouse gas emissions, and build community resilience. Our vision is an Alberta where people and nature thrive, and our mission is that we realize our vision by recognizing gaps, mobilizing resources, investing in our communities, creating partnerships, and building capacity across sectors. We offer a suite of programs, grants, and investments and strategic engagement initiatives that align with our focus areas, including climate resiliency and emissions reduction, as well as nature-based solutions and conservation, and of course, the circular economy as well. Alberta Eco Trust Foundation operates all across Alberta, so we recognize the traditional territories of many diverse Indigenous peoples, and this includes Treaty 6, Treaty 7, and Treaty 8 nations, the Blackfoot Confederacy comprising of Siksika, Kainai, Piikani First Nations, the Cree, Dene, Nakota Sioux, Saulteaux, and the Métis Nation of Alberta. MBIX is a collaborative initiative of Alberta Eco Trust, and we bring together the building industry to share knowledge, build capacity, and support building and renovation practices all across Alberta. And the goal of MBIX is to reduce emissions from new and existing buildings across Alberta. And we do this by hosting events, sharing resources, and developing and strengthening connections and skills of people and organizations through training, peer-to-peer learning, and communities of practice, as well as knowledge exchange events. So CLF Alberta is our local hub here of the Carbon Leadership Forum, and we coordinate local events that empower industry professionals to radically reduce carbon from buildings and infrastructure. A diverse mix of professionals join our events, including architects, engineers, contractors, sustainability consultants, material suppliers, building owners, and policymakers. Our events include informative presentations and interactive group discussions that range from topics related to embodied carbon. And we aim to build local industry capacity to design and construct buildings and infrastructure that radically reduce embodied carbon in the province. So today we have our co-chair of CLF Alberta, Christina Michalik, and she's also a project manager at Footprint. Christina has dedicated her career to championing sustainable initiatives in the building industry and providing advice to project teams, mentorship to colleagues, and volunteering. She's managed sustainability certifications and strategies for a diverse range of clients in Alberta, BC, and Ontario, from landmark healthcare projects like the Calgary Cancer Centre to interior fit-outs to improve energy performance of existing buildings in commercial and educational settings. Christina is especially passionate about life cycle assessments and leverages her expertise and knowledge in the area to help clients identify and reduce the impact of embodied carbon in both new and existing buildings. So with that, I will hand it over to Christina to introduce our speaker and our topic today.
Excellent. Thank you so much, Alicia. Really appreciate everybody being here today to take into this great webinar on concrete steps to net zero, practical strategies for low carbon construction. We are here today with Shane Mulligan at Heidelberg Materials. Shane is the sustainability marketing manager, where he is responsible for all aspects of sustainable sales and marketing efforts in North America. So really excited to be having him here today to be able to talk this further. Shane, I'm going to throw it over to you to start your discussion.
Perfect. Thank you very much. Just get this slide up there.
Sorry, and I'll just mention as well that we will have a Q&A as well for the duration of the event. So feel free to throw your questions in there and we'll answer them at the end.
Thank you. Well, thanks very much for having me today and for the interest of those that are joining online to participate in this webinar here today. A little bit of context before we jump into the main deck. Who are Heidelberg Materials? Well, we're a vertically integrated construction materials company headquartered out of Heidelberg, Germany. We specialize in cement, concrete, and aggregates. And our North American headquarters are located in Irving, Texas. Meanwhile, I'm located in Calgary, Alberta, in what we call our Northwest region, which is essentially the Manitoba-Ontario border west to the coast, and then includes also the states of Washington and Oregon. And we're unique a little bit as well that in the Northwest region, we also have concrete pipe and some asphalt divisions as well, which isn't super commonplace throughout our entire network. But cement, concrete, and aggregates are definitely the main core of our business and what we're concentrated on in North America. And like a lot of companies that are out there, we have a lot of different commitments around sustainability. We have 2030, 2050 sustainability goals and different targets associated with hitting those goals. And as part of those targets that we've set for 2030, we've also rolled out what we call our concrete promises. These were rolled out at our capital markets day last year. There were about 10 different promises that we made to the market and our shareholders, but the ones I typically like to highlight as part of these presentations are highlighted here on the screen. The one to draw your attention to is that 50% of our revenue will be generated from sustainable products by 2030. That includes products that meet certain carbon thresholds, but also those that incorporate circularity principles like the use of recycled concrete aggregate. I think we're currently at around the 35 to 40% range of our revenue now is in that range. So we've got a little bit to go to get to that 50% target by 2030. Another one is this 400 kilograms of CO2 per ton of cementitious material. That figure probably feels somewhat abstract to many on this call, but the old rule of thumb used to be that 1,000 kilograms of cement meant 1,000 kilograms of carbon. That's changed a little bit with some best practices that have been rolled out globally. And for context, the carbon intensity of our best plant in North America is located in Delta, British Columbia, just outside of Vancouver. And that has an EPD that says 679 kilograms of CO2 per ton of Portland limestone cement out of that facility. So quite a ways to go to that goal of 400 kilograms. That's a global target, so that averages out what we're doing in Europe and other areas of our operation, but nonetheless is a very ambitious target for us to reach. And then the other one, if I have time to go into at the end, I'll highlight a little bit more, is our goals around carbon capture, utilization, and storage, where we target capturing 10 megatons or 10 million tons of CO2 through carbon capture technologies at some various facilities throughout the world by 2030. But getting into a little bit more of the detail of today's presentation, we're here to talk about embodied carbon, and I think that there's probably a general understanding of what embodied carbon means among those that are participating in this call. But some of the drivers for embodied carbon, we're starting to see come a little more to the forefront in our day-to-day activities. We have quite a number of different regulations and policies that are being rolled out across Canada and throughout North America that are focused in on reducing embodied carbon in the built environment. And these are above and beyond the requirements that you might be pursuing with the LEED Green Building Rating System or the Net Zero Building Standard with the Canadian Green Building Council. And if you're in an area like Vancouver or the city of Langford or even in the city of Edmonton, there's some policies that are starting to affect day-to-day projects. And when we're talking about embodied carbon, we're generally talking about concrete. Because concrete, as you know, is one of the largest embodied carbon contributors to most types of infrastructures. When we're talking concrete in the built environment and particularly vertical construction, we find that 50% is generally the ballpark of where concrete is contributing to the overall carbon footprint of a building. Sometimes it's a little bit less, like in a residential single-family home, but it could even be more if you're looking at a very tall high-rise building that has a very deep parkade structure. You could be looking at a concrete contribution to your project of about 70% or so, which creates a little bit of a problem, but it also creates a bit of an opportunity as well to really dig into concrete and look for lower carbon concrete opportunities to help lessen the impact that concrete is going to be contributing to your project while still getting the benefits that concrete provides from a structural perspective, from a climate resilience perspective, et cetera. So I'm going to be digging in today as part of today's conversation about some of the practical strategies to help enable that. But understanding that everyone's familiarity with concrete is probably at a slightly different level, I've got this slide to set a little bit of context as to why the carbon footprint of concrete is so high. So you may have heard the stats that concrete generally represents somewhere between 5 to 8% of global greenhouse gas emissions. That is a very large amount of emissions to be associated with one industry. If concrete was a country, it would be the third largest country in the world next to the United States and China. So there's definitely a lot of heavy lifting that the industry is able to do or needs to do to lessen that impact. But this graphic helps to illustrate where that impact is coming from. So it's a life cycle assessment of concrete as a material, where you're looking at the mining of the raw materials themselves, which generally is not a carbon intensive process. You're taking raw limestone to help make your cement, raw gravel and sand out of local quarries. It's generally just a little bit of dynamite, some on-site emissions associated with diesel trucks, etc. In the grand scheme of things, though, very small contributions to the carbon intensity of concrete. Then you have the cement manufacturing process itself. And that really is the elephant in the room when it comes to the carbon footprint of concrete. Despite representing only 10 to 15% of the concrete mix, cement contributes somewhere in the range of 80 to 85% of the total carbon intensity of that concrete. So it is definitely the main contributor to why concrete is considered a carbon intensive material. And that relates to the process of making cement itself. There are two main contributors to increasing the carbon intensity of the cement manufacturing process. One of those is known as combustion emissions, which is related to the burning of fossil fuels to heat the cement kilns to the 1500 degrees Celsius that's necessary to make cement. That's generally achieved using materials like natural gas or coal, or in some cases petcoke, which burns a lot of CO2 into the atmosphere as a result of those high temperatures, and ultimately represents somewhere in the range of about 30% of the total cement intensity for emissions. The other 70% is related to the chemical reaction that happens within the cement kiln. As that limestone goes through the kiln with various other mineral elements, there's a process that occurs that's called calcination, a natural byproduct of which is CO2, and those are what's known as process emissions. And without carbon capture technology, those process emissions are considered irreducible, that you cannot make Portland cement without undergoing this calcination process. And so a lot of the different strategies that the industry is looking at are focused just on that concept of carbon capture and storage to reduce that. As we move more into the concrete side itself, once you take those raw materials and start mixing the concrete, that process is not particularly carbon intensive. It varies a little bit where you are geographically. The colder climate that you're in, the more natural gas you might be consuming. Depending on what grid you're in at, you might be consuming electricity from various sources. But in the grand scheme of things, the mixing process doesn't add a lot to the overall carbon intensity of the concrete mix. And then further down the life cycle assessment with concrete, you have the transportation of the concrete. Concrete's a time-sensitive product. It starts to harden after too long of a transportation distance. So those transportation distances are generally small. No matter where you're at in Alberta, there's most rural communities have at least one concrete producer that's able to facilitate concrete pours in that local geography. Urban centers have a lot more options available to help reduce that overall transit intensity. And then from a use perspective, concrete is famously durable and long-lasting. Not a lot of maintenance or repair or replacement that's necessary over the life cycle of a building. Whether it's a 60-year lifespan or a 100-year lifespan, concrete stands up relatively well versus other construction materials. And then finally, at end of life, concrete is generally considered endlessly recyclable, being able to be put back into fresh concrete in some circumstances, or be used in other applications such as road-based or sub-based work with asphalt construction or concrete. So having an understanding of where the emissions are coming from helped to understand how we arrive at low carbon concrete. And low carbon concrete is basically two things. It's reducing the carbon intensity of the cement that you're consuming. And as a vertically integrated manufacturer of cement and concrete, we're busy on both sides of that equation, trying to reduce that impact. But more so on the concrete side, it's how do you make the most efficient use of that cement that you're putting into the concrete to help lessen the impact in the overall matrix of that concrete that you're making. And at Heidelberg, we have a branded low carbon concrete offering. It's known as EvoBuild. And EvoBuild is a tiered offering that provides increasing levels of carbon savings when compared against an industry average benchmark. And in Canada, the benchmark that we've utilized for this program is the 2017 Canadian Ready Mix Concrete Association industry-wide EPD, which was built by essentially taking a survey of a statistically representative number of concrete plants throughout Canada, figuring out what a typical concrete mix looks like for 20 MPa, 25 MPa, 30 MPa, etc., assigning carbon intensities for all the different constituents that make up that mix, and figuring out what an average carbon intensity is for 35 MPa, 45 MPa, etc. concrete. Our EvoBuild structure looks at those carbon intensities on average, and essentially, if we're able to provide a carbon reduction in the range of 30 to 50% versus those benchmarks, we call that an EvoBuild bronze product. If it's 50 to 70% savings, that's EvoBuild silver. 70 to 85, it's gold. And then if one day we can reach the goal of a net zero product, we would call that an EvoBuild zero product. That's not to say that every one of these levels are available in any given market. When we start looking at some of the golds and zeros, those are obviously unattainable at this time and represent more ambitions of where we want to go. But generally speaking, most of our markets are comfortable offering bronze level carbon savings, and some applications are able to accommodate silver as well. The way that we deliver these carbon reductions is really about materials engineering principles, and our technical service teams are generally looking at the different levers that are at our disposal to help reduce the carbon impact of the concrete matrix as a whole. That involves looking at the aggregate gradations to get better particle packing and more strength out of the aggregate structure in itself, which helps to be able to pull out some of the cementitious content that might be going into that concrete. Looking at different novel admixtures or different combinations of admixtures to help either reduce the water demand or increase the strength of the concrete mixes is another strategy that's becoming more typical. And there's a lot of great research that's going on in that space to help strengthen the concrete and reduce the cementitious contents. Secondary cementitious materials, that's looking at things like fly ash, waste product from the coal industry, or slag, which is a waste product from the steel industry. Generally speaking, in Alberta, we're concentrated mostly on fly ash. And that's probably the most popular lever, and the one that people generally have in mind when they're talking about lower carbon concrete is using materials like fly ash to displace the amount of cement that's going in to your concrete mix. But we're also trying to move away from that as being the de facto solution. That yes, it is a significant lever that we can pull to help reduce the carbon intensity of your mix, but it's not a full scale or holistic view of the overall carbon intensity of the concrete. And we're trying to focus more now on the global warming potential of the concrete matrix as a whole, but nonetheless do utilize some of those SEM strategies. We also look at different cement types, and that generally refers to the use of Portland limestone cement, which has been introduced in the Alberta market in the last couple of years. And a lot of work is going on at the CSA level to increase the amount of limestone that's allowable in a PLC mix and maybe limit the applications that can go into. Another really powerful lever for us is the days to strength maturity. So, concrete is typically measured 30 MPa in a 28-day strength time horizon. If we're able to extend that out to a 56-day horizon or 91-day horizon, that is a very significant lever to allow us to pull out some of that cementitious content, increase the amount of SCMs we're using relative to cement, and make a relatively sizable impact on reducing the carbon intensity of the concrete. But that's not always an option. A lot of times we're actually seeing schedule demands requiring us to go the other way, where we're looking at higher early strength concrete applications in high rises and suspended slab type applications. And we can still design lower carbon mixes to meet those performance targets. They're just not going to be as low carbon as they would be if we are able to extend that schedule out. And then many of these new solutions are also able to be enhanced with some of the different digital technologies that exist that I may touch on a little bit later if there's time. But at the end of the day, for any given application that we're looking at, we're really starting with performance. There's certain performance expectations that concrete needs to meet, regardless of what the carbon intensity is going to be. And then we start looking at the levers to make sure that we're still hitting performance, but pulling each lever to the maximum extent possible, balancing the trade-offs that might be there with schedule and cost as well. But performance is definitely still paramount with the various solutions that we introduce with our EvoBuild options. But not everybody that is in the design space that is looking at reducing the carbon intensity of their project is familiar with a lot of the specifics and nuances that come with concrete. And it is important to be at least educated on a high level as to what some of the implications are of some of these different levers and solutions that I highlighted on the previous screen. And in particular to the use of SCMs like slag and fly ash, it seems like a very easy lever for us to pull to be able to reach 20%, 40%, 70% substitutions. But there are important trade-offs to be aware of when you're looking at those different types of strategies. And it's really great to work with your concrete producer to figure out what works for your local project, for your local environment, to have a good understanding of what that means. But generally speaking, as you start to substitute higher levels of fly ash or slag, you start to see impacts on the performance of your concrete mix, some of which include reducing the curing time, so slowing down the schedule that strength gain is happening within that concrete matrix. So that might not be an option past 20% in fly ash, for example. As you start to move to 25, 30%, 35% substitution, you might be incurring schedule impacts to your concrete that are just not acceptable with your construction goals. Or even if you're looking at things like the pumpability or workability or finishability of the concrete, the amounts and types of SCM you're utilizing can impact that. And it's important to have that understanding in balancing what you're trying to achieve with the carbon reduction goals that you're examining. Additionally, there's some on-site considerations that come into play when you're looking at higher levels of substitution rates. And these graphics come from CRMPA Low Carbon Concrete Guideline, where they look at different options for 35 MPa concrete, different substitution rates. And at 15%, that's pretty much the concrete that everybody's used to. There's no additional curing requirements on site. But as you significantly increase that substitution rate from 15 to 42.5 or even 50% that's highlighted in the bottom right of the screen, there are additional curing considerations. And again, that's going to impact your construction processes, but also potentially the construction schedule. And again, it's just making sure that you're aware of these implications that as you're starting to look at the different options that are available to you. Exposure class is another important consideration. As concrete is exposed to more and more aggressive environments, whether it's chloride penetration, sulfates in the soil, road salting, whatever the case might be, the concrete matrix needs to be denser to help stand up to that attack. And so as you get more aggressive exposure classes, you get more dense concretes, which generally has the effect of increasing your carbon intensity because you're using more cementitious content to hit those higher densities. And unfortunately, within environmental product declarations that are being published right now, it's not mandatory to highlight what exposure class your concrete is being designed towards. And so we're finding a little bit of an imbalance right now as to how EPDs are being used and compared because that factor is not currently being listed on your EPDs. And speaking of EPDs, I think everyone is probably largely aware of them on the call, but
well, we suspected that,
There we go. Thank you. There's probably a good understanding on this call, but generally speaking, EPDs are referred to as nutrition labels for construction materials or other types of materials, where instead of highlighting the calorie content or the salary content associated with a food item, you're looking more at the global warming potential / carbon intensity of that material on a per ton or per cubic meter basis, as well as a whole host of other environmental impact categories that may be relevant depending on what type of project that you're interested in. That nutrition label concept is represented very visually on an EPD, where it highlights some of the key environmental impact categories. And generally speaking, the one that people are most interested in is just the global warming potential or the carbon intensity of the product. This one number here, this 224 kilograms of CO2 per cubic meter. But it's important to know that that one number is actually made up of three numbers, three modules within a life cycle assessment that represent the product stage of an evaluation, which looks at a cradle to gate scope of that product, which is comprised of these three modules. Module A1, which is the extraction and upstream production of the raw materials themselves, which, as alluded to earlier in concrete's case, is very much disproportionately driven by the cement content, more specifically the clinker content, which is the intermediate product of the cement manufacturing process. Then you have module A2, which is the transportation of those raw materials to your production site, which is going to be dependent on both the haul distance, but also the mode of transport. So within our network of concrete production facilities, we typically find that our best performing EPDs are coming out of our Metro Vancouver area. And that's largely because they're able to transport their aggregates by barge on the waterways that run through Metro Vancouver. That option is not available in every marketplace. You can't do that in Fort McMurray, where there is no water-based transportation. And so there's this disparity between truck transportation and water-based transportation that does have an impact on your EPDs and how low you're ultimately able to go. Then finally, there's module A3, which is the manufacturing component itself, which I briefly touched on earlier. That's just looking at your natural gas consumption, what type of electricity you're using, your fuel use on site, waste that you're generating on site, et cetera. And again, when we look at our network of concrete facilities, British Columbia is slightly better advantaged than Alberta because they're running on hydroelectric electricity, whereas we're functioning on natural gas. And all of this is just to say that you could have the exact same mixed design in Vancouver that you have in Edmonton, but you're going to have vastly different results because of these local considerations that factor in to the ultimate calculations. But in terms of how we make an impact and start to lower our carbon beyond just the levers that are available to us, these next slides kind of go into some best practices that have been outlined by that CRMCA low carbon concrete guidance document, which includes some general strategies about looking at things like smaller sections for your floor sections, maybe using a higher strength concrete, which might seem counterintuitive, to lessen the overall section that you're looking at. Maybe reducing a slab thickness from 8 inches to 6 inches could be possible with a higher strength concrete with a net benefit of a lower concrete impact. Or looking at your column spacing within your buildings or whatever the case might be. Document goes into some great detail there. But the biggest recommendation that they have within this document that I want to really echo throughout today's presentation is around the concept of collaboration and integrative design teams, because the most successful projects that we've observed that are targeting lower carbon objectives come with the collaboration between the concrete supplier, the general contractor, the testing agency, and then the owner, which is generally represented by the designer. So constantly working together to figure out what the objectives are, properly communicate them, discuss what trade-offs exist and which are acceptable and not acceptable at the early design stages, but then also at touch bases along the construction process are extremely beneficial to hitting your carbon goals for your projects. Another really big recommendation or concept to be aware of for encouraging lower carbon concrete in your project specifications are favoring performance-based specifications over prescriptive specifications. And generally speaking, in the built environment for vertical construction, most specifications we come across are performance-based. They reference CSA, which is a performance-based specification in Canada. We tend to encounter more prescriptive specifications when we're looking at horizontal infrastructure with public work agencies or provincial agencies, where for sidewalks, for example, they might say you must have a minimum cement content of 300 kilograms of cement per cubic meter of concrete, a maximum amount of 20% SCMs, no SCMs as of November 1st, or whatever the case might be. These exist because there have been issues in the past, and they're trying to create a level playing field for all the concrete production in that local marketplace, but they're extremely prohibiting when it comes to being able to lower the carbon intensity of your concrete. And so allowing your concrete producer to present different alternatives and pull levers that they're familiar with really helps in achieving your goals for carbon reduction. But the main concept I'm going to kind of highlight here for the remaining portions of these slides is the concept of a concrete carbon project budget. And this is a concept that is really growing in popularity across North America and Canada specifically. There's been some recent guidance that's been published that helps to provide details on how to accomplish the goal of a carbon budget for concrete. But there's also starting to be some regulations and policies and codes and standards that are also following this approach as we look at the market and how it's responding to incorporating lower carbon goals into your projects. This includes the guideline to specifying low carbon ready-mix concrete in Canada, which is published by the Canadian Ready-Mix Concrete Association. It's where a lot of the images on the previous slide come from. It's where the details on how to implement a carbon budget come from as well. We've also seen the recent publication of the ACI 323 low carbon concrete code, which also highlights the concept of a carbon budget. And there are a couple policies that have been introduced in Canada from the Treasury Board and the City of Langford, which is a small municipality out there in Vancouver Island, that have also adopted this approach that I'm going to highlight in more detail here today. And some are even going above and beyond. It's not just about conducting a carbon budget for your project, but then demonstrating a reduction against it. That when you actually go to procure your concrete, you're procuring concrete that can give you an EPD that demonstrates a reduction at a project level at these different percentage levels that are being introduced from about 10% at the lowest end to all the way up to 40% that we're seeing in the LEED Green Building Rating System version 5. So it is something of which to be aware. Really simply speaking, this is an illustration of what a carbon budget looks like. Essentially what you're doing is taking each element that you're looking to specify for your project in a table format, outlining what the strength requirement is from a performance perspective for that element, what the relative exposure class is for that given element, and then setting a maximum global warming potential threshold for each of those individual elements. The important thing is that you're not enforcing that criteria at the mix-to-mix or element-to-element basis, but instead multiplying each of these global warming potential thresholds by the respective volume that you are projecting for each of those elements to get a total amount of carbon, which you then add up to create a budget at the project level. And that is your objective for your project, where you are enforcing the limits so that perhaps a concrete producer can't quite hit 306 for the footings, but they can hit 290 for the columns. And the ultimate impact of that is that they still come in underneath your goal, and it provides that added layer of flexibility for implementation. In terms of where you should be getting those thresholds, the industry average, the industry recommendation for or best practice is to reference your local regional industry average EPD. So for Alberta, we have the Concrete Alberta Regional Industry Average EPD that outlines for various strengths of concrete what a recommended benchmark should be. And so in Alberta's case, they have a slightly lighter green color to highlight what a recommended benchmark would be for a concrete of a certain strength with or without air exposure conditions. And generally speaking, across all the different mixes that are included within this EPD, it represents a type GU cement with 10 to 20% SCM use, which varies depending on the given element. And the caution I would exercise with using this document is that you really just want to concentrate on this light green number. All the numbers that are located to the right are more designed for concrete producers so that they can demonstrate by submitting this document that if they're attesting that their mix is using a type GUL or Portland limestone cement concrete with a given amount of SCMs, they can suggest that their concrete is representative of some of these lower numbers and demonstrate adherence to the carbon budgets that are being set for these projects. Some of the projects that we see being specified across Canada and North America are a little more aggressive, where they're trying to go right to the farthest end of the scale and pulling out the lowest number to put in their carbon budgets, which really limits the amount of concrete producers that are ultimately able to supply that project, because only a handful of concrete producers have gone down the road of being able to generate product and industry or product and facility specific EPDs to demonstrate a specific number for that project. Most concrete producers are using this document in the interim to help demonstrate their process and how they get to these lower numbers. And if you specify this lower number, you can also kind of reduce the number of levers that are available to hit lower targets. So if you're saying that you want a concrete that's representative of a Portland limestone cement with 20% fly ash, now you're looking at needing 25 or 30% fly ash to get beneath that number, which then again might have some schedule implications and not allow your target to ultimately be reached. Highlighted on the screen here is an example of what a product and facility specific EPD would look like. So a number of producers are able to generate these for specific facilities located in Alberta and beyond, that for the specific mix that's being represented at a specific plant that it's coming from, it generates a global warming potential number that's specific to that concrete, which really helps these producers be able to demonstrate their adherence to those goals that are being set at the project level. So that's really high level introductions as to what a carbon budget is, but it's really glosses over a lot of the finer points that come up with concrete. Concrete generally is thought of as a commodity product that is only made up of 5 to 8 ingredients for any given mix. But those proportions really matter. Those implications that I talked about earlier when it comes to schedule and exposure class also really matter. And so it's also important to be aware of what is a traditional concrete versus what is a specialized concrete. And there's guidance provided by the CRMCA documents, but also right in some of these regulations that are being rolled out by different government entities that try to recognize and accommodate what these specialty mixes would look like and increase the allowances within a carbon budget to properly represent them within a given project. And the recommendation is that basically when you are looking at a specialized concrete mix, whether it's a high strength requirement, cold weather application, or other specialty circumstance, that you're multiplying that global warming potential benchmark by 130% so that you're accommodating all the extra cementitious content that you're going to need to meet those performance considerations. It's not a perfect number. It doesn't reflect the 24-hour higherly strength mix versus a 72-hour higherly strength mix, but it's at least something to allow for some of that flexibility in your design process, and an important step to be aware of. So I also highlighted within this concrete carbon document that I've been referencing quite a bit throughout this presentation is a bit of a rundown of what those specialty circumstances might look like. Higherly strength applications, architectural concrete, low shrinkage concrete, self-consolidating concrete, etc. Ultimately, the conservative approach is that for any application you encounter that's not listed specifically within an EPD, that you would use this 130% approach. But I, again, encourage you to reach out to your local concrete producers to talk about what the implications are for any given element, any given concrete mix that you're considering, and they should be able to give you some guidance as to what an appropriate buffer is for those types of special conditions. And then this slide ultimately just kind of reflects, based on that previous example, if you were to implement for a floor and slab as an example, incorporate that 130% multiplier to increase your overall carbon budget as part of that process. But generally speaking, it's a relatively straightforward exercise that can be accomplished in an Excel spreadsheet. But what we're seeing as we're starting to encounter a few more projects that are starting to outline these carbon budgets in various markets throughout Canada is that all of them are wrong. When you project out what a carbon profile is going to look like for a given project, you have your start where it's 0, you have your end 2 years down the line, 1.5 years down the line, where you're coming in at that 900,000 kilograms for that total project. But what we're seeing in reality is that you're off base before the project's even really started. And this discrepancy that exists between what you've budgeted and what actually is occurring in the field is generally related to those specialty conditions, the higherly strength concretes, the cold weather concretes, whatever the case might be. And it's just because those special considerations are not making their way into the process, in that budgeting process, that they're not being properly captured in that original projection. And so again, what I really would suggest as part of this process on a go-forward basis, and one of the learnings to take away from today is that you want to work together and have your conversations very early on from a designer perspective, calling on your concrete producers, having conversations with your general contractors about what does the schedule look like, what concrete options exist, and what are the trade-offs that are acceptable and not, are very important in setting a more realistic carbon budget to get closer to what's actually occurring out there in the field. And then the other thing to keep in mind is that carbon budgets are an iterative process, that you need to do these at a number of different project stages to get more and more accurate and encapsulate the decisions that are being made, that need to be made as part of the construction process. So at a very conceptual design level, when you build a carbon budget, it's super high level. You're just kind of specifying out, are you considering wood or steel or a concrete building? You don't have a lot of details on volumes. It's a very high level design. As you get further down the process with your design process, you start to call out certain elements. You have a better understanding of what the exposure classes are going to be, and you can start to build out kind of a first pass at what a carbon budget is going to look like. As you move into construction, that's probably the first opportunity you have to really start to accommodate schedule, that, as you're putting into your project specifications, your carbon budgets and your objectives for a process, you should be asking of your construction teams that are bidding on that project that they should submit some sort of carbon budget process that's reflective of the schedule that they're ultimately putting forward. That will come with the concrete producer considerations from the conversations that they'll have on the side. But once that project is awarded, it's important then to get together as part of that integrative design team concept and really walk through the different phases of construction and have a serious conversation about what is important versus what's not, and what's realistic for a carbon budget against the pressures of cost, schedule, performance, safety, and the like. And then it's important then throughout the construction as well to maybe have milestones at every 6 months to get back together, see how you're tracking against your carbon budget, what's still coming up, and what decisions can be made at that point. And then at the end of the project to have a little bit of a review to see how you performed, see where you went wrong, and incorporate those learnings into the next phase, or next design, I should say. So the final slide I have around carbon budgets are just some of the keys to success, or some of the do's and don'ts when it comes to implementing these carbon budgets into your regular design practices. The first one is, again, just reiterating this concept of integrative design team. When you look at LEED, any version of LEED that's ever come out, one of the prerequisites is to have an integrative design team. That hasn't always involved your concrete producers, but it's definitely important to bring them to the table, as they have a significant influence on the overall carbon performance of your project. And it's important to have those conversations about trade-offs, as I've alluded to. A couple times I've highlighted throughout this presentation as well, when you're looking at schedule, that is the biggest driver when it comes to what's possible with low carbon concrete and what's not. So having an understanding of where your high early strength applications are is very, very important. But also considering what mitigation strategies exist. We have some newer technologies with maturity monitoring sensors that can tell you how well a concrete's performing, which can create a little bit of a feedback loop as a project's ongoing to help you make incremental improvements as you go along with your high early strength concretes. So it's definitely important to leverage the technologies that are available and the data that helps to back it up. Similarly, when it comes to considerations around workability, placeability, finishability, how smooth you want your floors, etc., those are considerations that have a pretty big impact on what's possible or not with low carbon concrete. And so when you're specifying certain requirements for finishability or flatness of a certain concrete element, it's important to provide some context as to why that's your target, and work with your general contractor and your concrete producer to discuss what type of pumps you have or will be using relative to the concrete mix you're looking at, because different amounts of cement, different aggregate sizes is going to have an influence on what's actually possible for your carbon intensity of that product. We talked a little bit about data availability, industry average EPDs, product specific EPDs. It's getting more and more commonplace that concrete producers have this data, but it's definitely not representative of every mix that exists on any given day. There are tools that are under development right now that are helping to better automate EPDs, create carbon budgets more on the fly, and create different alternative evaluation scenarios. But there are still concrete producers that don't know what an EPD is, and that's, they haven't encountered them yet. So there's quite a disparity depending on where your project is located. But ultimately, you have what you have at your disposal. You have the industry average EPDs. You have concrete producers that you can lean on to have your conversations. You're not necessarily going to have the specific element benchmark for every single application you're looking at, but that's okay. You don't need that level of granularity in every circumstance. As long as you're falling back on those key engineering levers that are available for you, from aggregate gradations to SEMs to different admixture technologies, and working with your concrete producer to maximize those where possible, you're going to achieve the best result. You might not be able to predict what that best result is going to be up front, but you're going to achieve it if you're enabling these levers throughout your performance-based specifications. And then the last one I would recommend is with relation to conducting a bit of a review. That once you've undertaken a project that has carbon goals associated with it, and worked with your contractor and your concrete producer to achieve the end result, have a review of how you've performed and pass on those lessons learned amongst the stakeholders that were involved in that project, and start to participate in some of these groups like Carbon Leadership Forum, or the Canadian Green Building Council to help pass on those learnings, figure out where we can fill the gaps with the different data sources, and start to make progress overall. And in the interest of time, I think I'll stop there for any questions that we might have on today's presentation.
Excellent, Shane. Thank you so much. We do have a question regarding, I guess, challenges. What challenges do you see in achieving consistent data availability across different concrete producers in Alberta and beyond?
Yeah, that's a good question. As I kind of alluded, the data consistency, there's a lot of disparity from one concrete producer to the next. But there are a number of different third-party tool providers and even concrete producers who are taking this into their own hands, or QC systems that are taking this into their own hands to better represent the data or the mixes that are being produced and better organize that data on a go-forward basis. I think I just heard a stat this morning, actually, that the concrete industry published more EPDs in April of this year than all of last year. So they're coming very rapidly, and more concrete producers are getting on board, which also creates some possible future challenges with administering the different data that's out there and making sure you're getting representative data for your local geography. But it is coming. So it's more of a hold tight situation, but I would imagine the next 2 to 3 years, we're very automated in this process.
Okay. Amanda, I see that you unshared your camera, or sorry, started sharing camera. Did you have a question you wanted to ask?
Yeah, I do actually.
Great.
So thanks so much, Shane. That's very informative. You talked a little bit about performance requirements. I wanted to ask you about regulatory approval, specifically with airports around civil and structural engineering standards. Has EvoBuild used or certified for, has it been used or certified for airport applications? So your terminals, your taxiways, your runways, and is that something that you're working with technical databases or testing? You can speak a little bit to that.
Yeah, so I would say horizontal infrastructure of any kind, whether it's roads and bridges or airport infrastructure, is lagging behind because they are very prescriptive in nature, and it's very difficult to alter those specifications because there's a lot of resistance to change, but also they exist for a reason. There may have been issues in the past that have led to the decisions that have been made. So a lot of it is case-by-case basis, working very early on when a project is identified with YYC or YEG to propose the different solutions, get them comfortable, provide them test results, whatever the case might be, to demonstrate that the concrete will meet performance requirements or the requirements of that application. And there have been limited instances of success. We've had a couple sidewalk projects that have gone on in both Calgary and Edmonton that have utilized lower carbon concrete, diverging away from their prescriptive specifications. And we have an example at the Edmonton airport as well for one of the recent upgrades. They did a repair job. They utilized some EvoBuild concrete as well.
Okay, so basically, it's like with the ACI standards and FAA guidelines. It's not necessarily that you're not meeting them. It's that we just haven't. A project hasn't gone ahead and actually gone through the rigor and ultimately the application process.
Generally speaking, yes.
Okay.
Yeah. Oh, Christina, you're on mute there.
Rookie mistake on my part. Thank you so much, Amanda, for your question there. All right, another question we have for you as well is, where is environmental reporting at the product and project levels evolving, in your opinion?
Well, in my opinion, yeah, similar to the previous answers, that it's evolving very quickly. And I know internally here, we're looking at some tools to really kind of leapfrog to the next level, to go just beyond just a mix specific EPD to project level reporting, and then even customer level reporting or region level reporting, to really start to inform customers and design teams on what are the implications for your past project, your current project, and what alternatives exist. Well, how could you perform better? How will you perform better in the future? These are the insights that are coming very rapidly. I would imagine the next year and a half, we have some pretty cool tools that we can revisit at one of these types of sessions.
Absolutely, thank you. All right. Do we have any questions from the audience as well? Feel free to share your screen and to unmute yourself as well if you have a question. Otherwise, I do have another one I'd like to ask as well, but I would happy to get something from the attendees today as well.
I have one more question. Clean Energy Canada came out with their report, a great report around cost. Can you provide a little bit of a cost comparison between like the Evo build, bronze, and your standard classic concrete, or is that more specific for like regional and volume-based variations?
Yeah, I'll give my least favorite answer as from my consulting days in my past is it depends. It depends very much on a lot of the specifics. Like you mentioned, regionality factors in, supply chains really factor in. It varies a lot from producer to producer. I would say one of the important things to be aware of as a designer or cost estimator is that it used to be the case that supplementary cementing materials were less expensive than cement, that your fly ash and your slags were cheaper than typical cement. That has changed quite a bit in recent years. Those SEMs are becoming more expensive. Whether they're more expensive than cement or at parity with cement, it again varies on the region that you're in. But that has project level implications, low carbon concrete implications. And the market's evolving there as well. We're in the prairies, as an example, we're moving away from fresh fly ash, I'll call it, that comes from the coal industry towards harvested fly ash, where we're going back and finding deposits of fly ash that are nearby past coal operating facilities, taking it out of the landfill, processing it to get it consistent and usable in concrete. But all that processing has cost implications, has carbon implications, and unfortunately could rise the cost of lower carbon alternatives relative to non-carbon focused concretes.
Okay.
But generally speaking, it depends on your objectives. If you're looking at 10 to 20% carbon reductions, that's relatively low cost as an alternative. We're talking a couple percentage points or parity. But if you're getting more and more aggressive and we start to use more innovative technologies like admixtures, that's where the costs start to creep up.
Another great question, Amanda. Thank you. All right, another question, I guess, is recommendations. So if you have a project team that's looking to specify low carbon concrete, and we have to take into account the different performances, schedule implications, obviously, and the talk about the data limitations, what would your recommendations be for those projects and project teams?
Yeah, that's number one theme for this presentation is that collaboration, that engagement, more than once, like get together as soon as the project's awarded, have those important conversations and connect on a regular basis to make sure that everyone's on the same page. So it's not a surprise at the end of the day that you're 20% over because you had to construct your building in a year and a half or face penalties. Those expectations are clear, and there's an informed decision being made for your carbon considerations.
Thank you so much. All right, we do have some questions here from the chat as well. Will certificates of attendance, oh, sorry, that's for me, my certificates of attendance. What is the single most impactful action we can take in the next 12 months that directly contributes to our net zero target, and who is responsible for it?
I'd suggest that the first step is to measure. There's the old saying that what gets measured gets managed. And, we are in a little bit of early days with this data availability. And so being able to get really aggressive and say we're going to hit a 30% carbon reduction goal versus industry average is great. It's ambitious, but is it realistic? I think we're at the stage right now collectively that we got to start measuring it first, measuring not just at design, but at the as-built level. What is being achieved and what's realistically possible to move the needle.
Mm-hmm. So I guess a question in terms of as-built, as you mentioned that, in terms of projects that are looking to, when it comes to life cycle assessments, a lot of time the work almost stops at the end of design once that IFC set has gone out. For projects that are looking to do as-built, what type of suggestions would you suggest to include in maybe specifications or information to request from the contractor or concrete supplier in order to have that information later on? I guess it does go into part of the carbon budgeting, but yeah, would love to hear your aspects for that later stage information too.
I think including a requirement for environmental product declarations within your within your bid documents and enforcing it throughout the contracts is important. Again, it's great to target a reduction, but getting that information is probably step one. But being flexible, like allowing the industry average still until more and more concrete producers have had the opportunity to go down the road of product-specific EPDs. It's not as granular, but it's still good enough to help inform the success of a project.
So any additional questions from the chat at all, or anybody that would like to unmute themselves or show their video? All right. Well, it looks like that might be the end of our questions here, but if people still have some, feel free to do. Shane, really appreciate you being able to do. Oh, got some congratulations there from the team there for coming today and talking with us a little bit further about concrete. It's always a pleasure to have you collaborate with us. So thank you so much.
Thank you very much for the interest, and always open for any questions afterwards as well.
Excellent. And I think I'll hand it over to Alicia for the closing here.
Well, thanks, Christina and Shane. That was very informative, and I feel like we're all better for it. Especially, there were some really interesting facts in there. I particularly enjoyed the barge factoid about the transportation of Vancouver. I thought that was really interesting. So, thanks again to Shane from Heidelberg and Christina of CLF Alberta. Keep aware that we will be having some more CLF events. We've got some upcoming things happening at Buildex, which is being held in Calgary, October 22nd and 23rd. We'll be hosting a low carbon mixer on October 22nd. So please keep your eyes and ears peeled on the NBEX events website, which is at nbex.ca/events. And we look forward to seeing you at future webinars as well as our future in-person events. Thanks so much for joining us today, and we look forward to seeing you at the next one.
Thank you.